It's fairly low cost. They have a free plan and then a Teams plan, I believe. So it's not too much, but it is a really, really valuable tool, as you're going to see. So you can sign in here. I'm going to jump in with my Google account. There may be a bit of setup for your account, but I'm sure you guys are smart enough to figure out how to set up an account. I'm sure Relevance also makes it easy enough. So then we get taken to this dashboard where we see on this left hand side we have tools. So these are the tools easy enough. So then we get taken to this dashboard where we see on this left hand side we have tools. So these are the tools that I've talked about, where it's some kind of functionality that we can create and we can build it all on Relevance, no code, and there's even sort of extensibility, or you can add more functionality into Relevance by adding some low code components or even custom code. So Relevance is a really great base for building not only tools but then the agents that you can connect that into. And we're going to use the same Relevance tools that we make now in multiple of the different agents that I'm going to make for the rest of this video. So first things first, if we go back to the Figma here, we see we need to make 3 different tools. So tool 1 is Company Researcher. It's going to take in a company URL, it's going to search the web, and it's going to return a summary. So that's the functionality we need. Let's go and create a new tool. I'm going to call this Research Company. We can give it a cool little I'm going to zoom this up for you guys. Hopefully that's the right size. Search. Have fun with the stuff, guys. Like if it's putting stupid emojis on things to enjoy it, then that's what you need to do. Like if you make it a chore, it's going to feel like a chore, right? Now we get to descriptions. This is something we're going to see recurring. But basically, as you know, as we learned in the concept section, we need to have natural language descriptions of our tools and of our APIs so that the agent's going to read those descriptions and understand what the agent or what the tool does and what those different parts of it does. So you'll see this recurring throughout this, but first things first, what does this Research Company tool do? Takes in, oh, I got caps lock on, takes, and there's also some tutorials here if you want to go deeper. Relevance has some great documentation as well, but it takes in a company URL and scrapes their website, then returns a summary, an AI generated summary. So then to build a tool, we need to have some kind of input. You don't always need an input, it can actually just be triggering, but generally you're going to have some kind of input that the agent needs to pass into the tool. In this case, to research a company, it's going to need to take in some text, which is going to be a URL. We're going to say company URL. We're going to say to research a company, it's going to need to take in some text, which is going to be a URL. We're going to say company URL. And then again, here we have another description. You see, describe how to fill this input. This is again going to help our agent within Relevance AI and elsewhere, as you'll see in tutorial number 4, why this is so important to add in the descriptions right. So this is a URL for a company. To be researched. Must be in the format https:// dot 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 dot. So we need to have the HTTPS for this to work. So that's going to be our input. Now, if this seems a bit confusing, just stick with me. It will make sense in a second. This stuff, if there's anything that I've learned from picking up so many different tools, like when I first got into Facebook ads, when I've got into building these kinds of agents, it's you feel completely overwhelmed, but that's all just part of the process. And what feels difficult now is not going to feel difficult forever. So just please stick with me. And it's a really, really great feeling once you go and be like, this was hard a few weeks ago and now it's really easy. So we've got our first input. That's what the research company tool is going to do. And then we need to define our steps. So the next step, we can go add. I'm going to hide this so we get a bit more space. Add step. Now the cool thing about Relevance is that it comes with a lot of great functionality out of the box. Here's one, extract website content. We have LLMs, we have Google searching, we have all sorts of AI generations, replicate, knowledge bases as well. There's so much cool stuff on here, and this is why I really rate Relevance as one of the best platforms. If you were to go all in and want to upskill, you can build so much on this. So I'm a big fan. I love the Relevance team and what they're doing. So the initial plan for this build, I was going to use the extract website content, which is fairly straightforward. We can say, oh, one other thing, the company URL. We are going to be using this company URL throughout our tool here. So we can change this text to say something more descriptive. So company underscore URL. You guys are gonna think and write like coders now, because you need to use some kind of syntax and use some kind of variable naming convention. This is a standard one, or you can do things like company URL camel case, but I prefer this format as I'm mainly a Python kind of guy myself. Now that we have that named, we can use it in these kinds of fields. So here you can see it pops up user inputs. So basically when this tool is run, it's going to take the inputs or the information we put in the inputs, and it's going to pass it to different steps and use them as we describe within the builder here. So let's run this quickly. Let's put in my company, https://morningsi.ai, and then we can click runs. And then we can click run here. So that's going to go to my website and scrape the information off of it. There we go. So it's got all of this, but you see it's just pulling back the first page, and this is why I shuffled this around, and I want to show you guys how to do something a bit more advanced. I know this is supposed to be a beginner tutorial, but this is not really that useful, and it's a very easy thing for me to just bump this up to a little bit more valuable. While relevance tool here is great, we can do better. So we're actually going to delete this. You can use that step for all sorts of other things, but I really like what's called Firecrawl Web Scraper. This is a cool app, firecrawl.dev. Shout out to the guys at Firecrawl. Basically, if we then go I should see if they can do it, morningsi.ai, and they'll do a free scrape for us here. So this is just going to do the single URL, just like we got in relevance. But the difference here is if we then go to crawl, if you hover over this, it's going to crawl a URL and all of its accessible subpages outputting the content from each page. So instead of just taking that front page, it's actually going to crawl through multiple things. So this is really from each page. So instead it's going to is if we then go to crawl, if you hover over this, it's going to crawl a URL and all of its accessible subpages outputting the content from each page. So instead of just taking that front page, it's actually going to crawl through multiple things. So this is really the first cool thing or first skill that I want to put in your tool belt is that you have things like Firecrawl that you can use through relevance. They have things like map, which is just going to output all the URLs that it finds. Then there's other things here where you can use AI to extract data. I'm not going to go into that. But what we want is this crawling functionality from Firecrawl. Where you can use AI to extract data. I'm not going to go into that. But what we want is this crawling functionality from Firecrawl. So I'll put a link in on the school post that comes with this video. It'll, again, first link in the description to go to the school. And if you go to the YouTube resources section, there will be a whole post on this, and all the resources will be in there. It'll also be in my free course on school as well. So you can find it in the classroom section. So you want to sign up to Firecrawl so you can get an API key. It's very easy. We can just go through with Google. Again, this is not sponsored. There's zero sponsoring going on through any of these tools. I guess I'm kind of sponsoring my own tool because I'm putting it at the end, but I'm not getting paid a dime for any of this. I'm really just trying to put you guys on what I like to use, what's made me money, what's made me a more valuable AI automation expert or developer for my companies and for the companies you work with. AI automation put you guys on what I like to use, what's made me money, what's made me a more valuable AI automation expert or developer for my companies and for the companies you work with. Continue, and then you get to the dashboard here. Might look a bit scary, but what you can do is go to the API keys. So you can click on create an API key here. YouTube. I'm having issues with mine. It should be fine for you. I've already got an API key, but once you get the API key, what you can do is take it and come back here to relevance, and you can go into the side panel here where you're going to delete this. You can use that step for all sorts of other things, but I really like what's called fire crawl. Firecrawl from each page. So instead of I'll open Google and then key of. Once you get the API key, what you can do is take it and come back here to relevance. And you can go into the side panel here, where is it? Settings. And then we have our API keys. So we're going to need to add more into this later. So keep an eye on this. This is something you need to be familiar with. And you can scroll down to Firecrawl and you just pop it into this Firecrawl API key section here, and you're good to go. And you can come back. Oh, no, we don't want to duplicate that. Now we've got our Firecrawl set up. We need to make a couple of things. We need to do a couple of tweaks here. We have, of course, if you want to get those variables up, you can go bracket, or curly bracket, which is shift to get those. I don't know why it's not popping up. There we go, company URL. If we hover over this, we can see it says scrape the provided URL only, uncheck if we want to crawl instead. So if we want to get that crawl functionality that we just saw, that we think we want to get all the data, we can uncheck it. And then we want to extract the main content. So you might have to just trust me on that one, that we don't want to have all of the other rubbish. We just want the body of the website. A number of pages. We don't want this to take too long. You can expand this much more, but I'm just going to go for, say, 5 for now, just to keep it quick. And then now what we can do is run this again. We've still got my URL up here. We can go run step. Give it a second. You will at some point have to pay Firecrawl. Of course, it's not a free service, but they do have a free plan, so you should have no issues with getting that. So here you can see we're getting a lot more data back from this web scrape than we were with just the relevance version, which is great. So the next step is we have this data. We want to generate some kind of research summary so that we can send that to our sales rep once they have requested it. So now it gets into the fun part of writing LLM prompts. For this one, sometimes you need to really go and make a big effort, which we are going to do later, as you'll see. But in this case, we just want a quick summary. I'm going to throw one in here that I made earlier. All of this will be available on the Figma, or it'll be given somewhere in the resources, all right? But we just need something quick and dirty here. It's not really a massive part of the project, so it's okay to just whack one in there. So bang, I've got it in there. Can you please take this website content and summarize it into a 300 300-word natural language summary, which clearly outlines where they're based, their values, etc. Anything that would be helpful to know for a sales rep who will soon be on a call with them. Break it into key areas like overview, product and services team, etc. And I've got a couple of things here to make sure that it doesn't mess up, which it was doing for me a bit in testing. So we do want to put in, if we go curly bracket, we want to put in the FireCall data here, which is going to be all the website data that came back from our scrape. We want to then insert it into this prompt here. So I hope you're starting to, the things in your cogs in your brain are starting to click into gear here. And then we get to select the model. For this, it's pretty basic task. So I want something quick and cheap. For many of you, it's going to be easiest to work with the OpenAI APIs because you probably already played around with your API key before, which I'll show you how to do in a second. But let's go with GPT-4o Mini. But Relevance, of course, does have support for all of the other models. But my tendency for most tasks now is to actually go for some of the Google models that have come out. Again, you guys might be watching this in a year or whatever. It might be quite different. But at the moment, Google is really leading the way with making the cheapest models possible. And they're actually really good as well. The price decrease on using things like Google Gemini Flash Lite and Google Gemini Flash 2.0 and stuff like that, it's ridiculously cheap and it's also a really good model. So it's a bit more difficult to get APIs on the Google side. So I'm just going to stick with OpenAI for this tutorial. So let's go GPT-4o Mini. And then we need to, of course, set up our API key. If you scroll down, where is the OpenAI? So to get your OpenAI API key, you need to go platform.openai.com. The playground. Get your OpenAI API key, you need to go platform.openai.com. Playground/playground, sorry. This will again be linked in the resources, or you can just type up platform.openai.com. I'm sure you'll find it. If you haven't already, create an account and sign in, and then you need to go to your dashboard here. You go on the left side, you go to API keys, and you click create a new secret key, and then you're going to be able to copy that key an enterprise consulting, chatbot development, a company dedicated to empowering businesses, autonomous Morningside, and then we can go run step and see what this company researcher tool is going to output for us. Boom. Morningside AI is a leading artificial intelligence development company dedicated to empowering businesses, autonomous AI agent development, enterprise consulting, chatbot development team. They got it keep me out of my own team page, damn. But yeah, so there you go. That's the company researcher tool. That's step one. I hope you guys can kind of see how that works now. A cool thing about Relevance is there is this build section, which we've just gone through, but you can also go to use, and this can be really helpful when sharing these kinds of tools. So this is not really only just an AI agent tutorial. I'm also teaching how to build tools, because you can build very valuable tools in something like Relevance, and then you can go share, you can go publicly available. Oh, and I can click this, and then I can give to my employees, I can give to the companies that I'm working with, the clients that I've solved these kind of services on, and then they get a nice and handy tool like this. I mean, I use these throughout my organization. for like description generation, a lot of content repurposing. There's tons and tons of different use cases for building these kinds of tools. And then you can take this URL and you can share it around to whoever you want. So this is a great way to use relevance. Let's go back to our tool here. But for now, we need to keep moving along so we can get this first agent done. So that's the first tool. I'm going to run through it a bit quicker now that we know how these kind of tool buildings work. I'm going to create a new tool here. I'm going to call it this time, if we go back to our Figma. And I recommend when you guys are building your agents, you're building systems and planning them out, this kind of laying out in a Figma. If you're not familiar, this is Figma. It's like a design software, but you can also use it for kind of whiteboarding. It's called a FigJam board. It's one of the types of boards that you can do. And I use this all the time with my team as well. It's like, if you can't take what I'm telling you, lay it out on a board so that I can review it and give you notes, and then we all agree this is the build. There's often a lot of communication issues with explaining functionality. So this AI agent layout, it's really helpful. You can, if it's maybe a workflow automation, you can do box, arrow, all of this, laying out how it's going to be built. Here I've done it for you in a very basic format. So we've done this first one, maybe I just make this green. Second one is going to be prospect researcher. So this takes in a LinkedIn URL. Searches the web and returns a summary. And you're going to see how I tied this all into an agent shortly. So we're going to go research prospect into an agent. The URL searches the web and returns a summary. And you're going to see how I tied this all into an agent shortly. So we're going to go research prospect, still takes in a LinkedIn URL, right? Scrapes the profile and then generates an AI summary of the prospect. Input, we're going to need a linked and URL, the linked and URL of the prospect. And we rename this. Now we're going to add a step, and relevance has got us here linked. Get a LinkedIn profile or company post. So this is cool because then we can pop in our LinkedIn URL here. Oh, we don't need two of them. So we're going to get the user profile here. Then if I put in mine, my LinkedIn profile, if you guys want to connect with me on LinkedIn, more than welcome. So we're going to get the So we've done this first one. Maybe I just make this green. Second one is going to be prospect researcher. So this takes in a LinkedIn URL, searches the web, and returns a summary. And you're going to see how I tied this all into an agent shortly. So we're going to go research, prospect, still shortly. So we're going to go research. Search, prospect, still takes in a linked and URL, right? Scrapes the profile and then generates an AI summary of the prospect. Input, we're going to need a linked and URL, the linked and URL of the prospect. Let me rename this. Now we're going to add a step, and relevance has got us here linked. Get a LinkedIn profile or company post. Linked. Now we're going to add a step, and relevance has got us here linked. Get a LinkedIn profile or company post. So this is cool because then we can pop in our LinkedIn URL here. Oh, we don't need two of them. So we're going to get the user profile here. Then if I put in mine, my LinkedIn profile, if you guys want to connect. Years company founded, tons and tons of great information that you guys can use, and we are going to use shortly. So this is really cool. I would probably add one more step to this if I was taking this and building it for my own team, I would add in another LinkedIn scrape here where we just do the same thing, but we'll also get the posts, because posts can give you a bit more up-to-date information on what they've been doing recently. But you guys can add that, and you just go add a step, LinkedIn, and you do the same thing as we've done here. But you guys can add that, and you just go add a step, LinkedIn, and you do the same thing as we've done here. But you change this to LinkedIn post, get user posts. So that may be a cool thing for you guys to add the functionality on at the end as a bit of a challenge. You can pause this video and do that. And then we need an LLM step to take this. Again, I'm going to grab a pre-written prompt that I did just to save some time. I'm going to drop this in here. It says fairly similar stuff. LinkedIn data. I'm just going to put all the data in there. And then we're going to use a GPT-4o Mini again. And we can give that a run because we've already got this data. Queued up here, and there we go. We've got a nice summary. If I change this to nice and formatted, so there's a little button down there between raw or formatted, and you can copy the stuff out of here, of course. So Liam Watley, my followers, damn, I got a lot more than I thought. So then we have the summary, my name, where I'm based, information, my career experience, super handy stuff. And this is going to be super helpful in the next step when we generate that pre-call report. So very quickly, we've created one more tool. I'm going to save this. So now we've got, if we go back to our Figma, we have 2 of these done. Now the final one is going to take in the company and prospect research and generate a pre-call report. So this one's going to be a little bit different. If I go create a new tool, pre-call report. So pre-call takes in company and prospect summary and generates a pre summary in there. I hope you're following along. Next step is just an LLM step, and we want to combine these two together. Again, I've got a little handy prompt for this to save us time. Now in this case, you will see that the prompt is a bit bigger, right? So this is for more important parts when you are creating tools, whether it's for agents or just generally when you're using prompt engineering and LLMs to create value. In this case, we are creating value because in this case, we're taking in this prospect summary and this company summary, and we're also giving it the context of this fantasy or hypothetical business that we are selling this agent to as like a co-pilot system. We've got Big Boy Recruits, which is a Dallas-based recruitment firm specializing in software industry talent acquisition for SMBs. You're going to see this kind of recur across the different projects we do, but basically we're helping these big boy recruits to automate their business with AI. So this takes in some context on that business, and it's going to generate a report that's going to help the sales rep say, okay, this is the company, this is what we sell, this is what we specialize in, this is the company that we're trying to sell to, this is who we're going to be talking to. How can I personalize this call, or what's the strategy I can go into this with? What are some angles that I can attack this call from? And so to do this, I have a prompt writing tool that I use quite regularly, and my team uses it as well. Perfect prompt. So this tool does a lot of legwork for myself and my team all the time. I'm going to give it to you guys to use for free. You'll be able to clone it into your Relevance account. Basically, what I'll usually do is I'll put on the dictation thing. You've got it on one of these keyboards. You've got this little thing. Basically, whatever on your computer allows you to speak into the computer, and it takes in your voice and transcribes it into text on the screen. I'll press that, and then I'll explain, as you can see. And see here, what is this prompt doing and why? And I'll go, this prompt needs to do this, this, this. It's going to take in this information. It's going to do this. The reason we're doing this is this, this, this. And I'll do like a big body of text in there. And then the next one, if I have them, I'll give some good examples of input and output pairs of how I want it to take in data and how I want it to spit it out. If you give it both of these and you hit run, it's going to print you out using the research-backed prompting techniques that we use at Morningside. It's all crammed in here. There's a video that I recommend all of you watch. It's going to be in the free course anyway on School. So when you get in there and watch my prompt engineering guide, this is basically the entire information of that prompt engineering guide smashed into this LLM step here. So when you pass this information in, it applies all of that, and it gives you out a prompt that is fully research back and performs very well right out of the box. So that's a little bit of extra value I wanted to throw in there for you guys. This is going to be available on the School with the rest of the resources as well. So basically, I put in the information here about what this particular task was. I said it's going to take in the prospect information, it's going to take in the prospect summary and the company information, and it spat out this basically first go, and I just had to insert these variables. So this prompt and everything else will be on the School resources as well. So in this case, because we are doing a bit of strategy and sort of high level thinking rather than just summarizing, and we may want to change the model here to something a bit smarter, we could go to O3 Mini, which is one of the later ones. Again, when you're watching this, it might be O6 or O10 or whatever the hell they come up with next, but there's probably going to be some much better models, so just use a smart one, because it's really strategizing on how big boy recruits can position themselves for this call. So enough of me yapping about that. Let me grab some inputs for this and we can test it. Hot. Shadow NZ muscle. All right, so I've got this information here about myself, my LinkedIn profile, and my company. And so again, remember that this is for Big Boy Recruits, a Dallas recruitment firm specialized in software industry talent. Co-pilot, Big Boy sales co-pilot. Sorry, like I said, I got to have fun with the stuff where I go kind of insane. This agent is our sales co-pilot that helps reps to be better prepared for sales calls. Triggers, we don't need to do any of that. We go to core instructions. I'm going to again paste in some of the stuff that I've prepped earlier. So if I paste this in here, you'll see that it's structured fairly similarly to the prompt that we just did before for the pre-call report generator. And this is again using another tool that I've created for AI agent prompting. So it's fairly similar stuff that I include in that other prompting tool, but the agents is slightly different to just regular LLM steps within different tools and workflow automations. So I will include this as well. It's my AI agent perfect prompt generator, and it's fairly straightforward to use. I'll include that in there as well. But basically, you put in all the information about what the agent is, why it's doing it, the different tools that you're connecting to it, and then it prints out this for you. So I'll just run through it. We've got a role here telling it who it is, and kind of hyping it up and saying how good it is. Explains the task, talking about how it's helping to conduct detailed research on companies and prospects, some specifics. Don't need to worry about those too much, just reiterating the task. And now here we can enter in the references to tools. So if we go /tool, and see, in order to get the agent to function as well as possible, we need to tell it what tools it has available. This is really key across all the agents you build, especially if they're more conversational. You need to explain to them what tools they have and how and when they should use them. So if I go, you have 3 powerful tools: research company. Yep, that's right. Purpose, input company URL, use when needing to gather company information. This one, of course, is the prospect. And then this last one is our pre-call There we go. So that's all whacked in there. Don't need to worry about that too much. But again, this will be included, this prompt and everything, if you want to follow along. And also if you just want to clone the whole agent and use it in your own business or sell it or whatever you want to do. We also get to select the model here. I'm just going to keep it as GPT-4o Mini. I like some pretty fast responses here because agents, as someone's using it, it can feel really irritating if it's not responding quickly. So we've got all that built out. That's the core instructions and the prompt of the agent. We can go down to the tools section. It's got all the tools connected in here because we mentioned them in the prompt, and we can just go through and do some quick settings on here. I don't want to have to do an approval for it. Some tools you can say, look, they've got to give it a thumbs up before it can actually trigger it. Prompt for how to use, just some quick descriptions we can pop in here. I'm not sure why Relevance doesn't carry that over from the tool. I guess they're asking us to do it again for some reason. When you need to research a prospect linked in URL, we're going to say this is auto run as well. And then pre-call, change this to auto run as well. Use this when you need to generate a pre-call report from the company and prospect research. Alrighty, and there's all sorts of other cool stuff. Relevance, as you can see, is like abilities, subagents, metadata, extra stuff that you can build onto. But I just want to get you guys started with the core of this. Alright, so we can confirm that. And boom, we have our agent here ready to go. So this is where you can test your agents and use them if you want to. But in this case, I'm just going to give it a quick rundown and say, see if the functionality is working as we planned. Hi, I am getting on a call with Liam Otley from Morningside AI. Here are his details. Or we can just go LinkedIn. Get me a pre-call report, please, to prep for the call. Sending your task to Big Boy Sales Copilot. And then we get to see all the debug and how it's actually walking through these different steps. Oh, let's see what he does. Yep, okay, that's great. It's using the research company as we wanted it to. Should add in one more step there to research the prospect as well. There we go, using the second tool. It is pretty satisfying when this stuff works. And this is just a really basic one. Guys, I don't want you to think this is like, oh, well, that's pretty underwhelming, Liam. I'm trying to teach you the basics so that you can actually build on top of this. So if you get the bug, if you get the, like you get a travel bug, if you get the agent bug and you see the stuff and you're really interested, oh, look, there it is. Now it's filling out the prospect summary as the inputs. Surely we don't have to watch it do that. It's going to take a while. Am I really going to write that out word for word like that? But when you start to see this magic and you add in other cool tools and functionality, you test it on yourself, you can build like things for, maybe you want to do content, you make yourself a little content copilot, etc. There we go, to use all the tools and it should be spitting back and bam, there we go. So I hope that was worth the wait. Let's go through it now. Here is your comprehensive pre-call report for your upcoming conversation with Liam Otley from Morningside AI. Pre-call report. Talent acquisition under pressure. Morningside AI operates in a highly competitive AI and tech market. As they scale, finding specialized talent, engineers, data scientists, AI with a proven record can be challenging. That's scarily accurate because that is literally one of the biggest constraints that we have had to scaling Morningside long term, is it's just really, really hard. Even with my channel, it's so hard to find the right people and get them to commit as developers as well. So if you want to build a very big general AI development firm and AI automation agency, you need the best talent and you need to get a lot of it in so that you can scale up. So that's bloody spot on. Obviously this thing knows that's a good angle to sell through. But yeah, prospect analysis. Liam's a dynamic entrepreneur and thought leader. With a robust background in e-commerce, digital marketing, and AI, his journey reflects a passion for innovation and commitment to continuous learning. Again, that's pretty bloody spot on. Hands-on experience. So there you go. That is the Big Boy Sales Copilot for Big Boy Recruits. The cool thing you can do now, once you have built this, is you can go share. There's a chat UI, which I'm going to turn on now. There are chat widgets, so you can put them on websites and stuff like that. What I want to do is just pull this up because this is what you'd be giving to your client likely, or if you guys are going to start selling these to businesses, which again, we're touching on selling in the last section of this video. So how do you turn these into a business and start making money from it and selling these as a service and building these for businesses, which is really where the money's made. So there you go. And that's because you get AI. Alrighty, that.
To large language models like ChatGPT. And what I'm hoping to achieve in this video is to give you kind of mental models for thinking through what it is that this tool is. It is obviously magical and amazing in some respects. It's really good at some things, not very good at other things, and there's also a lot of sharp edges to be aware of. So what is behind this text box? You can put anything in there and press enter, but what should we be putting there, and what are these words generated back? How does this work, and what are you talking to exactly? So I'm hoping to get at all those topics in this video. We're going to go through the entire pipeline of how this stuff is built, but I'm going to keep everything sort of accessible to a general audience. So let's take a look at first how you build something like ChatGPT, and along the way I'm going to talk about some of the sort of cognitive psychological implications of these tools. Okay, so let's build ChatGPT. So there's going to be multiple stages arranged sequentially. The first stage is called the pre-training stage. And the first step of the pre-training stage is to download and process the internet. Now, to get a sense of what this roughly looks like, I recommend looking at this URL here. So this company called Hugging Face collected and created and curated this data set called FineWeb. And they go into a lot of detail in this blog post on how they constructed the FineWeb dataset. And all of the major LLM providers like OpenAI, Anthropic, and Google, and so on, will have some equivalent internally of something like the FineWeb dataset. So roughly what are we trying to achieve here? We're trying to get a ton of text from the internet, from publicly available sources. So we're trying to have a huge quantity of very high quality documents. And we also want very large diversity of documents because we want to have a lot of knowledge inside these models. So we want large diversity of high quality documents, and we want many, many of them. And achieving this is quite complicated, and as you can see here, it takes multiple stages to do well. So let's take a look at what some of these stages look like in a bit. For now, I'd like to note that, for example, the FineWeb dataset, which is fairly representative what you would see in a production-grade application, actually ends up being only about 44 terabytes of disk space. You can get a USB stick for like a terabyte very easily, or I think this could fit on a single hard drive almost. You can get a USB stick for like a terabyte very easily. So they would see in a production-grade application actually ends up being only about 44 terabytes of disk space. You can get a USB stick for like a terabyte very easily, or I think this could fit on a single hard drive almost today. So this is not a huge amount of data at the end of the day. Even though the internet is very, very large, we're working with text and we're also filtering it aggressively. So we end up with about 44 terabytes in this example. So let's take a look at kind of what this data looks like and what some of these stages also are. So the starting point for a lot of these efforts, and something that contributes most of the data by the end of it, is data from Common Crawl. So Common Crawl is an organization that has been basically scouring the internet since 2007. So as of 2024, for example, Common Crawl has indexed 2.7 billion web pages, and they have all these crawlers going around the internet. And what you end up doing basically is you start with a few seed web pages, and then you follow all the links. And you just keep following links, and you keep indexing all the information, and you end up with a ton of data of the internet over time. So this is usually the starting point for a lot of these efforts. Now, this Common Crawl data is quite raw and is filtered in many, many different ways. So here they document, this is the same diagram, they document a little bit the kind of processing that happens in these stages. So the first thing here is, so here they document, this is the same diagram, they document a little bit the kind of processing that happens in these stages. So the first thing here is something called URL filtering. So what that is referring to is that there's these block lists of basically URLs that are, or domains that you don't want to be getting data from. So usually this includes things like malware websites, spam websites, marketing websites, racist websites, adult sites, and things like that. So there's a ton of different types of websites that are just eliminated at this stage because we don't want them in our data set. The second part is text extraction. You have to remember that all of these web pages, this is the raw HTML of these web pages that is being saved by these crawlers. So when I go to inspect here, HTML of these web pages that is being saved by these crawlers. So when I go to inspect here, this is what the raw HTML actually looks like. You'll notice that it's got all this markup, like HTML. You have to remember that all of these web pages, this is the raw HTML of these web pages that is being saved by these crawlers. So when I go to inspect here, this is what the raw HTML actually looks like. You'll notice that it's got all this markup, like lists and stuff like that, and there's CSS and all this kind of stuff. So this is computer code almost for these web pages. But what we really want is we just want this text, right? We just want the text of this web page, and we don't want the navigation and things like that. So there's a lot of filtering and processing and heuristics that go into adequately filtering for just the good content of these web pages. The next stage here is language filtering. So for example, FineWeb filters using a language classifier. They try to guess what language every single web page is in, and then they only keep web pages that have more than 60Hi everyone. So I've wanted to make these tools. Okay, so So let's build ChatGPT. So there's going to be multiple stages arranged sequentially. The first stage is called the pre-training stage. And the first step of the pre-training stage is to download and process the internet. Now, to get a sense of what this roughly looks like, I recommend looking at this URL here. So this company called Hugging Face collected and created and curated this data set called FineWeb. And they go into a lot of detail in this blog post on how they constructed the FineWeb dataset. And all of the major LLM providers like OpenAI, Anthropic, and Google, and so on, will have some equivalent internally of something like the FineWeb dataset. So roughly what are we trying to achieve here? We're trying to get a ton of text from the internet, from publicly available sources. So we're trying to have a huge quantity of very high quality documents. And we also want a very large diversity of documents because we want to have a lot of knowledge inside these models. So we want large diversity of high quality documents, and we want many, many of them. And achieving this is quite complicated, and as you can see here, it takes multiple stages to do well. So let's take a look at what some of these stages look like in a bit. For now, I'd like to just
With Lucid, IT teams don't have to start from square one. Need a work order process? Describe what you need and generate a flowchart automatically with AI. Create technical diagrams, roadmaps, and plan projects faster using customizable templates. Streamline workflows and documentation by connecting Lucid with the apps you already use, like Jira.
Hi everyone. So I've wanted to make this video for a while. It is a comprehensive but general audience introduction to large language models like ChatGPT. I'd like to note that, for example, the FineWeb dataset, which is fairly
Data filtering and curation.
fairly representative, what you would see in a production grade application, actually ends up being only about 44 terabytes of disk space. You can get a USB stick for like a terabyte very easily, or I think this could fit on a single hard drive almost today. So this is not a huge amount of data at the end of the day. Even though the internet is very, very large, we're working with text, and we're also filtering it aggressively. So we end up with about 44 terabytes in this example. So let's take a look at kind of what this data looks like and what some of these stages also are. So the starting point for a lot of these efforts, and something that contributes most of the data by the end of it, is data from Common Crawl. So Common Crawl is an organization that has been basically scouring the internet since 2007. So as of 2024, for example, Common Crawl has indexed 2.7 billion web pages, and they have all these crawlers going around the internet. And what you end up doing basically is you start with a few seed web pages, and then you follow all the links. And you just keep following links, and you keep indexing all the information, and you end up with a ton of data of the internet over time. So this is usually the starting point for a lot of these efforts. Now, this Common Crawl data is quite raw and is filtered in many, many different ways. So here they document, this is the same diagram, they document a little bit the kind of processing that happens in these stages. So the first thing here is something called URL filtering. So what that is referring to is that there's these block lists of basically URLs that are, or domains that you don't want to be getting data from. So usually this includes things like malware websites, spam websites, marketing websites, racist websites, adult sites, and things like that. So there's a ton of different types of websites that are just eliminated at this stage because we don't want them in our data set. The second part is text extraction. You have to remember that all of these web pages, this is the raw HTML of these web pages that is being saved by these crawlers. So when I go to inspect here, this is what the raw HTML actually looks like. You'll notice that it's got all this markup, like lists and stuff like that, and there's CSS and all this kind of stuff. So this is computer code almost for these web pages. But what we really want is we just want this text, right? We just want the text of this web page, and we don't want the navigation and things like that. So there's a lot of filtering and processing and heuristics that go into adequately filtering for just the good content of these web pages. The next stage here is language filtering. So for example, FineWeb filters using a language classifier. They try to guess what language every single web page is in, and then they only keep web pages that have more than 65% of English, as an example. And so you can get a sense that this is like a design decision that different companies can take for themselves. What fraction of all different types of languages are we going to include in our data set? Because, for example, if we filter out all of the Spanish, as an example, then you might imagine that our model later will not be very good at Spanish because it's just never seen that much data of that language. And so different companies can focus on multilingual performance to a different degree, as an example. So FineWeb is quite focused on English. And so their language model, if they end up training one later, will be very good at English, but not maybe very good at other languages. After language filtering, there's a few other filtering steps and deduplication and things like that. Finishing with, for example, the PII removal. This is personally identifiable information. So as an example, addresses, social security numbers, and things like that, you would try to detect them, and you would try to filter out those kinds of web pages from the data set as well. So there's a lot of stages here, and I won't go into full detail, but it is a fairly extensive part of the pre-processing, and you end up with, for example, the FineWeb dataset. So when you click in on it, you can see some examples here of what this actually ends up looking like, and anyone can download this on the Hugging Face webpage. And so here's some examples of the final text that ends up in the training set. So this is some article about tornadoes in 2012. So there's some tornadoes in 2012 and what happened. This next one is something about, did you know you have two little yellow 9-volt battery-sized adrenal glands in your body? Okay, so this is some kind of a odd medical article. So just think of these as basically web pages on the internet filtered just for the text in various ways. And now we have a ton of text, 40 terabytes of it. And that now is the starting point for the next step of this stage. Now, I wanted to give you an intuitive sense of where we are right now. So I took the first 200 web pages here, and remember we have tons of them, and I just take all that text and I just put it all together, concatenate it. And so this is what we end up with. We just get this just raw text, raw internet text. And there's a ton of it, even in these 200 web pages. So I can continue zooming out here. And we just have this like massive tapestry of text data. And this text data has all these patterns. And what we want to do now is we want to start training neural networks on this data so the neural networks can internalize and model how this text flows, right? So we just have this giant texture of text. And now we want to get neural nets that mimic it. Okay, now before we plug text into neural networks, we have to decide how we're going to represent this text and how we're going to feed it in. Now, the way our technology works for these neural nets is that they expect a one-dimensional sequence of symbols, and they want a finite set of symbols that are possible. And so we have to decide what are the symbols, and then we have to represent our data as a one-dimensional sequence of those symbols. So right now what we have is a one-dimensional sequence of text. It starts here and it goes here and then it comes here, etc. So this is a one-dimensional sequence, even though on my monitor, of course, it's laid out in a two-dimensional way, but it goes from left to right and top to bottom, right? So it's a one-dimensional sequence of text. Now, this being computers, of course, there's an underlying representation here. So if I do what's called UTF-8 encode this text, then I can get the raw bits that correspond to this text in the computer. And that's what that looks like this. So it turns out that, for example, this very first bar here is the first 8 bits as an example. So what is this thing, right? This is a representation that we are looking for in a certain sense. We have exactly 2 possible symbols, 0 and 1, and we have a very long sequence of it, right? Now, as it turns out, this sequence length is actually going to be a very finite and precious resource in our neural network. And we actually don't want extremely long sequences of just 2 symbols. Instead, what we want is we want to trade off this symbol size of this vocabulary, as we call it, and the resulting sequence length. So we don't want just 2 symbols and extremely long sequences. We're going to want more symbols and shorter sequences. Okay, so one naive way of compressing or decreasing the length of our sequence here is to basically consider some group of consecutive bits, for example, 8 bits, and group them into a single what's called byte. So because these bits are either on or off, if we take a group of 8 of them, there turns out to be only 256 possible combinations of how these bits could be on or off. And so therefore we can re-represent this sequence into a sequence of bytes instead. So this sequence of bytes will be 8 times shorter, but instead. So this sequence of bytes into a sequence of bytes on or off. And so therefore we can re-represent this sequence into a sequence of bytes instead. So this sequence of bytes will be 8 times shorter, but now we have 256 possible symbols. Bytes will be 8 times shorter, but now we have 256 possible symbols. So every number here goes from 0 to 255 now. And so therefore we can rewrite the sequence of bytes will be 8 times shorter, but now we have 256 possible symbols. So every number here goes from 0 to 255. Now I really encourage you to think of these not as numbers, but as unique IDs or like unique symbols. So maybe it's a bit more, maybe it's better to actually think of these, to replace every one of these with a unique emoji. You'd get something like this. So to replace every one of these with a unique emoji, you'd get something like this. So we basically have a sequence of emojis, and there's 256 possible emojis. You can think of it that way. Now, it turns out that in production for state-of-the-art language models, you actually want to go even beyond this. You want to continue to shrink the length of the sequence, because again, it is a precious resource, in return for in your vocabulary. And the way this is done by running what's called the byte pair encoding algorithm. And the way this works is we're basically looking for consecutive ChatGPT. And what I'm hoping to achieve in this video is bytes kind of mental or symbols for thinking. that are very common. So for example, turns out that the sequence that are this works is we're basically looking for consecutive bytes or symbols that are very common. Bytes or symbols. And the way this works is we're basically looking for consecutive bytes or symbols that are very common. So for example, turns out that the sequence 116 followed by 32 is quite common and occurs very frequently. So what we're going to do is we're going to group this pair into a new symbol. So we're going to mint a symbol with an ID 256, and we're going to rewrite every single pair 11632 with this new symbol. And then we can iterate this algorithm as many times as we wish. And each time when we mint a new symbol, we're decreasing the length and we're increasing the symbol size. And in practice, it turns out that a pretty good setting of basically the vocabulary size turns out to be about 100,000 possible symbols. So in particular, GPT-4 uses 100,277 symbols. And this process of converting from raw text into these symbols, or as we call them, tokens, is the process called tokenization. So let's now take a look at how GPT-4 performs tokenization, converting from text to tokens and from tokens back to text, and what this actually looks like. So one website I like to use to explore these token representations is called TickTokenizer. And so come here. To the dropdown and select CL100K base, which is the GPT-4 base model tokenizer. And here on the left, you can put in text, and it shows you the tokenization of that text. So for example, hello space world. So hello world turns out to be exactly two tokens. The token hello, which is the token with ID 15,339. And the token space world, that is the token 1917. So hello space world. Now if I was to join these two, for example, I'm going to get again two tokens, but it's the token H followed by the token hello world without the H. If I put in two spaces here between hello and world, it's again a different tokenization. There's a new token 220 here. Okay, so you can play with this and see what happens here. Also keep in mind this is not this is case sensitive. So if this is a capital H, it is something else. Or if it's hello world, then actually this ends up being 3 tokens instead of just 2 tokens. Yeah, so you can play with this and get a sort of like an intuitive sense of what these tokens work like. We're actually going to loop around to tokenization a bit later in the video. For now, I just wanted to show you the website. And I wanted to show you that this text, basically, at the end of the day, so for example, if I take one line here, this is what GPT-4 will see it as. So this text will be a sequence of length 62. This is the sequence here. And this is how the chunks of text correspond to these symbols. And again, there's 100,277 possible symbols, and we now have one-dimensional sequences of those symbols. So yeah, we're going to come back to tokenization, but that's for now where we are. Okay, so what I've done now is I've taken this sequence of text that we we have here in the dataset, and I have re-represented it using our tokenizer into a sequence of tokens. And this is what that looks like now. So for example, when we go back to the FineWeb dataset, they mentioned that not only is this 44 terabytes of disk space, but this is about a 15 trillion token sequence of in this dataset. And so here, these are just some of the first 1 or 2 or 3 or a few thousand here, I think, tokens of this dataset. But there's 15 trillion here to keep in mind. And again, keep in mind one more time that all of these represent little text chunks. They're all just like atoms of these sequences. And the numbers here don't make any sense. They're just unique IDs. Okay. So now we get to the fun part, which is the neural network training. And this is where a lot of the heavy lifting happens computationally when you're training these neural networks. So what we do here in this step is we want to model the statistical relationships of how these tokens follow each other in the sequence. So what we do is we come into the data and we take windows sequence. So what we do is we come into the data and we happens computationally when you're training these neural networks. So what we do here in this step is we want to model the statistical relationships of how these tokens follow each other in the sequence. So what we do is we come into the data and we take windows of tokens. So we take a window of tokens from this data fairly randomly. And the window's length can range anywhere between 0 tokens, actually, all the way up to some maximum size that we decide on. So for example, in practice, you could see a token windows of, say, 8,000 tokens. Now, in principle, we can use arbitrary window lengths of tokens, but processing very long, window sequences would just be very computationally expensive. So we just kind of decide that, say, 8,000 is a good number, or 4,000 or 16,000, and we crop it there. Now, in this example, I'm going to be taking the first 4 tokens, just so everything fits nicely. So these tokens, we're going to take a window of 4 tokens, this bar, view, ing, and space single, which are these token IDs. bar, we're going to, just so everything fits nicely. So these tokens, we're going to take a window of 4 tokens. This bar, view, ing, and space single, which are these token IDs. And now what we're trying to do here is we're trying to basically predict the token that comes next in the sequence. So 3962 comes next, right? So what we do now here is that we call this the context. These 4 tokens are context, and they feed into a neural network. And this is the input to the neural network. Now, I'm going to go into the detail of what's inside this neural network in a little bit. For now, what's important to understand is the input and the output of the neural net. So the input are sequences of tokens of variable length. So the input are sequences of tokens of variable length, anywhere between 0 and some maximum size, like 8,000. The output now is a prediction for what comes next. So because our vocabulary has 100,277 possible tokens, the neural network is going to output exactly that many numbers, and all of those numbers correspond to the probability of that token as coming next in the sequence. So correspond to the neural network is going to output exactly that many numbers, and all of those numbers correspond to the probability of that token as coming next in the sequence. So it's making guesses about what comes next. In the beginning, this neural network is randomly initialized. So, and we're going to see in a little bit what that means, but it's a random transformation. So these probabilities in the very beginning of the training are also going to be kind of random. So here I have 3 examples, but keep in mind that there's 100,000 numbers here. So the probability of this token, space direction, the neural network is saying that this is 4% likely right now. 11,799 is 2%. And then here, the probability of 3962, which is post, is 3%. Now, of course, we've sampled this window from our dataset, so we know what comes next. We know, and that's the label, we know that the correct answer is that 3962 actually comes next in the sequence. So now what we have is this mathematical process for doing an update to the neural network. We have a way of tuning it, and we're going to go into a little bit of detail in a bit. But basically, we know that this probability here of 3% we want this probability to be higher, and we want the probabilities of all the other tokens to be lower. And so we have a way of mathematically calculating how to adjust and update the neural network so that the correct answer has a slightly higher probability. So if I do an update to the neural network now, the next time I feed this particular sequence of 4 tokens into the neural network will be slightly adjusted now, and it will say, okay, post is maybe 4%, and case now maybe is 1%, and direction could become 2% or something like that. And so we have a way of nudging, of slightly updating the neural net to basically give a higher probability to the correct token that comes next in the sequence. And now you just have to remember that this process happens not just for this token here, where these four fed in and predicted this one. This process happens at the same time for all of these tokens in the entire dataset. And so in practice, we sampled little windows, little batches of windows, and then at every process happens at the same time for all of these tokens in the entire dataset. And so in practice, we sampled little windows, little batches of windows, and then at every single one of these tokens, we want to adjust our neural network so that the probability of that token becomes slightly higher. And this all happens in parallel in large batches of these tokens. And this is the process of training the neural network. It's a sequence of updating it so that its predictions match up the statistics of what actually happens in your training set. And its probabilities become consistent with the statistical patterns of how these tokens follow each other in the data. So let's now briefly get into the internals of these neural networks just to give you a sense of what's inside. So neural network internals. So as I mentioned, we have these inputs that are sequences of tokens. In this case, this is 4 input tokens, but this can be anywhere between 0 up to tokens. And this is the process of training the neural network. It's a sequence of updating it so that does. In the beginning, it's It's totally random predictions. But it's through this process of iteratively updating the network, and we call that process training a neural network, so that the setting of these parameters gets adjusted. Such that the outputs of our neural network becomes consistent with the patterns seen in our training set. So think of these parameters as kind of like knobs on a DJ set. And as you're twiddling these knobs, you're getting different predictions for every possible token sequence input. And training a neural network just means discovering a setting of parameters that seems to be consistent with the statistics of the training set. Now, let me just give you an example of what this giant mathematical expression looks like, just to give you a sense. And modern networks are massive expressions with trillions of terms probably. But let me just show you a simple example here. It would look something like this. I mean, these are the kinds of expressions. Scary. We have inputs x, like x1, x2, in this case, two example inputs, and they get mixed up with the weights of the network, W0, W1, 2, 3, etc. And this mixing is simple things like multiplication, addition, exponentiation, division, etc. And it is the subject of neural network architecture research to design effective mathematical expressions that have a lot of kind of convenient characteristics. They are expressive, they're optimizable, they're parallelizable, etc. And so, but at the end of the day, these are not complex expressions. And basically, they mix up the inputs with the parameters to make predictions. And we're optimizing the parameters of this neural network so that the predictions come out consistent with the training set. Now, I would like to show you an actual production-grade example of what these neural networks look like. So for that, I encourage you to go to this website that has a very nice visualization of one of these networks. So this is what you will find on this website. And this neural network here that is used in production settings has this special kind of structure. This network is called the transformer. And this particular one, as an example, has 85,000 roughly parameters. Now, here on the top, we take the inputs, which are the token sequences. And then information flows through the neural network until the output, which here are the logit softmax, but these are the predictions for what comes next, what token comes next. And then here, there's a sequence of transformations and all these intermediate values that get produced inside this mathematical expression as it is sort of predicting what comes next. So as an example, these tokens are embedded into kind of like this distributed representation, as it's called. These tokens are embedded into kind of like this distributed representation, as it's called. So every possible token has kind of like a vector that represents it inside the neural network. So first we embed the tokens, and then those values kind of like flow through this diagram. And these are all very simple mathematical expressions individually. So we have layer norms and matrix multiplication. And then those values kind of like flow through this diagram. And these are all very simple mathematical expressions individually. So we have layer norms and matrix multiplications and softmaxes and so on. So here's kind of like the attention block. block of this transformer, and then information kind of flows through into the multi-layer perceptron block and so on. And all these numbers here, these are the intermediate values of the expression. And you can almost think of these as kind of like the firing rates of these synthetic neurons. But I would caution you to not kind of think of it too much like neurons, because these are extremely simple neurons compared to the neurons you would find in your brain. Your biological neurons are very complex dynamical processes that have memory and so on. There's no memory in this expression. It's a fixed mathematical expression from input to output with no memory. It's just a stateless. So these are very simple neurons in comparison to biological neurons, but you can still kind of loosely think of this as like a synthetic piece of brain tissue but you can still just a stateless. It's a fixed mathematical expression from input to output with no memory. It's just a stateless. So these are very simple neurons in comparison to biological neurons, but you can still kind of loosely think of this as like a synthetic piece of brain tissue if you like to think about it that way. So information flows through, all these neurons fire until we get to the predictions. Now, I'm not actually going to dwell too much on the precise kind of like mathematical details of all these transformations. Honestly, I don't think it's that important to get into. What's really important to understand is that this is a mathematical function. It is parametrized by some fixed set of parameters, like say 85,000 of them. And it is a way of transforming inputs into outputs. And as we twiddle the parameters, we are getting different kinds of predictions. And then we need to find a good setting of these parameters so that the predictions sort of match up with the patterns seen in the training set. So that's the transformer. Okay, so I've shown you the internals. So that's the transformer. Okay, so I've shown you the internals of the neural network, and we talked a bit about the process of training it. I want to cover one more major stage of working with these networks, and that is the stage called inference. So in inference, what we're doing is we're generating new data from the model. And so we want to basically see what kind of patterns it has internalized in the parameters of its network.